All right, so we've actually done pretty well. So through all of this, we finally figured out what decision trees actually are. We know what they represent. We know how expressive they are. We have an algorithm that lets us build the decision trees in an effective way. We've done just about everything there is to do with decision trees. But there's still a couple of open questions that I want to think about. So here's a couple of them I want you to think about, and then we'll discuss them. So far, all of our examples that we've used, all the things that we've been thinking about for good pedagogical reasons, we had not only discrete outputs, but we also had discrete inputs. So one question we might ask ourselves is, what happens if we have continuous attributes? So Michael, let me ask you this. Let's say we had some continuous attributes. We weren't just asking whether someone was an animal or whether a human or whether it was raining outside, but we really cared about age or weight or distance or anything else that might have a continuous attribute. How are we going to make that work in a decision tree?
Well, I guess the literal way to do it would be for something like age to have a branching factor that's equal to the number of possible ages.
Okay, so that's one possibility. So we stick in age, and then we have 1.0. We have one for 1.1. We have one for 1.11. We have one for 1.111.
I see. All right. Well, at the very least, okay. What if we only included ages that were in the training set? Presumably, there's at least a finite number of those.
Oh, we could do that. We could just do that. Except, what are we going to do then when we come up with something in the future that wasn't in the training set?
Oh, right. Can we look at the testing set?
No, we're not allowed to look at the testing set. That is cheating, and not the kind of good cheating that we do when we pick good representation.
Okay, fair enough. Well, we could ranges. What about ranges? Isn't that the way we cover more than just individual values?
Give me an example.
Say ages, in the 20s.
Okay, so, how would we represent that with a decision tree? Let's say in the 20s?
Age.
How would we do that?
You could do like age, element sign, bracket,
20s.
20, comma, 21, or 29, or 30, right paren.
Yeah, it's too much. Why don't I just say age is between let's see, greater than or equal to 20 and less than 30. And just draw a big oval for that. Right? So that's a range. So that's all numbers between 20 and 30, inclusive of 20, but not 30. Right?
Yep.
And what's good about that is that's a question. You are either in your 20s or you are not. So the output of that is actually true or false.
So I guess the good news there is that now we know how to evaluate attributes like that because we have a formula from ID3 that tells us what to do. But it seems like there's an awful lot of different ones to check.
Right. And in fact, if it's truly a continuous variable, there are in principle an infinite number of them to check. But we can do now the sort of cheating you wanted to do before. We could just look at the training set, and we could try to pick questions that cover the sorts of data in the training set. So for example, if all of the values are in the 20s, then there's no point of even asking the question. You'd start to split instead upon values that were, say, less than 25 or greater than 25. And you can imagine all kinds of ways where you might do that. You might look at all of the values that show up in the training set and say, well, I'm going to do a binary search. So I'm just going to create an attribute for less than half of whatever's in the training set or greater than half of whatever the range is in the training set. Does that make sense?
Yeah, that's clever.
Right. Thank you. I just made that up on the spot. Okay, so you do those sorts of things, and that's how you would deal with continuous attributes. So that brings me to the next question. I'm going to actually do this as a quiz because I want an answer from our audience.